Hello, it's Duncan. Introducing tiny types in our last refactoring made item a lot simpler, but item type more complicated. Today we'll address that by adding operations to our non-negative-int, so that it isn't a tiny type anymore, but a grown-up Kotlin value class with functions and operators. So finally item feels like it can be a proper data class, and that's because we've made it so that all the values of its properties are acceptable. Now, whilst item is a lot better, item type is quite a bit worse. And that's because of all these items, quality value, dated quality value, all these dot values. And they're because we can't just actually treat a non-negative int as the type of the value inside it. If we want the value, we have to go and get it. That's a bit of a shame. I don't know whether the compiler could do better for us, treating a non-negative int like an int, but we can at least alleviate some of the pain by adding some operations ourselves. So let's go and have a look. So here's one place, item quality value minus updated quality value. If we were just to say, well, we'd rather not have to do that, then IntelliJ will offer to create a member function that will make everything better. So let's do that, non-negative-int minus. Okay, we'll name the parameter RHS for right-hand side, and we know that's a non-negative-int. Now, what should minus return? Well, if we're taking one non-negative int from another, we can't guarantee that we won't get a negative int. So we can't return a non-negative int from this. We could return an int though. And if we did, this would just be defined as this dot value minus right-hand side dot value. That makes this compile. And let's see whether it passes all our tests. It does. Should we add a test for minus? I think had we written this from scratch, we probably would. But as we refactored it, and as that looks like hard code to get wrong, I think probably in a code base used by a small enough number of people, I would just leave that alone, untested. Okay, back to item type. Here we have item quality value minus 2 times change. Well, again, if we just remove that and say, what would we have to do in order to fix that? IntelliJ will offer to create another member function, another minus, this one taking an int as its right-hand side. And for the same reasons, this can only return an int. It will return this dot value minus the right-hand side. It's a simple expression, and let's run the tests. And that also works. Back to item type. So we've got rid of 2 of the dot values. Here's another one, item with quality minus degradation. We could fix that one. Here's another one. So this is item quality plus improvement. Now, we could add a plus, or we can stick with the minus we've got and just subtract minus improvement. Let's have a look, see what that would look like. So we can say minus improvement. Does that work? It does. And we can take that out. So we're whittling away at those item quality value. Here we have another place where we might want to add an operation, adding non-negative ints to numbers, or vice versa. I think instead of doing that though, we'll try and make these all the same shape, because at the moment we have these ones here, which are with quality something minus something, in fact with quality the original quality minus something else. And this one we're actually setting the quality. So what I'm going to do is I'm going to say that this could be an operation. If this is the operation, this is degraded by. And there are 2 places that could be used. So that's one, and that's another. So in fact, we've replaced 3 of our with qualities with degraded by. And here we've got degraded by minus improvement. Well, that's not unreasonable. It allows us to have just one function. Now, can we cast this into degraded by? I think we can. In the case of passes, then we actually have an improvement, not degradation. So I'm going to call that improvement. And then the improvement is the amount that we've added to the value in each of these cases. So we'll take out right-hand side of these. And now we want to use degraded by, which it turns out we haven't made into an extension function yet. So let's do that. And then here we can say item degraded by our improvement minus improvement. And if we pass the cell by date, then we want to zero out, which is item.quality.value. And we're going to subtract that. Let's see whether that logic is right. We had the tests to lean on. And we're right. Now it'd be even nicer, of course, if we could just do minus item quality. And we can do that if we add unary minus. Again, we can't return a non-negative int from unary minus. That will have to be int, and that's going to return this dot value negated. Run our tests again. Okay, returning to item type, we're now using item degraded by all over the place, so we could make that into a member function or a method on item. Don't think we can do that automatically anymore. No, so let's just take that, cut it out of there, and put it into item. Removing the receiver and making it public. Check that all runs. Now we've got two ways of returning an item with a different quality. We've got degraded by and with quality, and it would be nicer for us to only have one. So let's see where this is now called. The answer is in our own degraded by method and then a whole bunch of other places and tests. So let's go and fix the test ones. Here, this is with quality value minus days. So that could be degraded by days. Item tests here, we're using with quality. So let's go and work out what we could be doing instead. No item should have its quality raised above 50 by updating. Well, in which case we could show that by saying degraded by -1. We'll pull the same trick here. Reduced below 0 by updating. It was 0. We're starting with item with 2. So if we were to degrade it by 3, we'd expect that to be capped to 0. Then keep a quality above 50. So if we degrade by 1, we should get 54. But if we degraded by -1, which should add to the quality, it should still stick at 55. Let's run the tests. So let's remake the search to find that we now have no uses of with quality that aren't item zone degraded by. So that suggests that we can inline this. And let's just have a look and see what we're saying here. We're saying we've got a quality cap, and maybe we should pull this into another variable. This is the value. Call it new quality. And we know that can't be negative because we're coercing it to be between 0 and quality cap. So we know that this null should never happen, but just in case, it's there. This Elvis is only to give us a good error message should we mess up somewhere. Run those tests. Good. So now item is probably as simple as it can be. We have a non-negative int with some helpful operations. And item type, similarly, quite simple. And all of the ways we update an item go through this degraded by. Now we might think of that another way. We might think of it as improved by, or we might want to add an improved by to express the difference between things getting better or worse. But this is at the moment quite nice and simple, and I think good enough. Now you may be saying, but Duncan, I can create an item with a non-negative int of 100 or 1,000 or something, which is more than the 50. If you remember, our rules were that items could keep a quality if it was above 50. I think there might be value in having a quality type that isn't just non-negative int, so that this maths happens in our quality type rather than in our item. I don't know if our system would be better or worse for that change, but I do know that it's good enough for now, so let's check in. So this is add operations to non-negative-int. I think that's probably good enough. Commit that. And that, I think, is good enough to commit to production. Next episode, we'll have a look at the pros and cons of introducing a quality type that isn't non-negative-int. If you'd like to see that episode, then please subscribe to the channel. And if you'd like this, then I suspect you'd like the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, published by O'Reilly, and details are in the show notes below. Thank you for watching.